Welcome for the third time. So in today's video, we'll be looking at the waves physics 101. But before we go into detail, first of the thing we need to understand what a wave is. So I'll say we need to know or to define what a wave is. So I can say a wave is the periodic disturbance right, that propagates. Is it okay? That's propagates or move with what? Energy, right? From the created point. Is it okay? So a wave is a periodic disturbance that propagates or move with energy from the created what? Point. So this is what we call the waves. So in the same waves, you have what we call basics types. These are what we call basics what? Types of waves. Basic types of the waves. Now the question is, what are the main basic types of the waves? So the basic types of the waves, the first one, it is what we call basic mechanical. That's the first one, right? Basic mechanical. So these are the types of the waves that requires the medium for them to travel, right? So these are the kind of the waves that requires the what? The medium for them to what? To travel. So this means that if there is no media, meaning that they cannot what? Travel. Is it okay? So I can say waves which requires a media. This is a media to travel, right? So these are waves which requires a medium to travel. So this kind of the waves, I can say the examples of the waves are, the first example that I can say, it is what we call water waves. So underwater waves, they require a media for them to travel, and the other one, it is what we call sound waves, right? And the other one, it is what we call seismic wave. So all of these waves, they require the media for them to travel. So meaning that if there is no media, they cannot what? Travel, right? So those are the main things that you need what? To take note of when it comes to that. Okay. And another type of the basic wave, or of the basics wave, it's what we call electromagnetic. So I'll say electromagnetic waves. So these kind of the waves, these are the kind of the waves which they doesn't require the media to travel. So I can say these are waves which does not require a medium to what? To travel. So they don't require any media for them to travel from one point into another point. So most of these waves, they're associated with these waves, they're associated with what we call associated with what we call they're associated with what we call the what? Electricity, right? Electricity and what we call magnetic what? Fields, right? Now, I can also say that the examples of these waves, I think we are so familiar with these, gamma rays, again we have what we call X rays, again we have what we call ultraviolet waves, again we have also what we call visible lights, we have also what we call infrared waves, and so on, or just like that. So these are what we call electromagnetic waves. Now the other one, it is, or the last, it is what we call matter waves. So when it comes to the matter waves, I can say that these are the waves that it's more like just a branch of physics which deals with what we call quantum mechanics. So it deals with quantum, I can say quantum what? Mechanics, right? These are what we call matter waves, and these ones, they're associated with electrons, protons, neutrons, all those, right? That's what they're associated with. So these are the main things when it comes to the waves. And the other part that you really need to know, it's what we call the properties of waves. Properties of waves. So the first property of wave that we need to take note of that the waves, they have what we call the amplitude, and the wave, they have also what we call the what? Frequency. And the wave, they have also what we call period. And the wave, they have also what we call what? Wavelength. And the wave, they have what we call wave speed. And the wave, they have also what we call the energy. So take note, they have the amplitude, frequency, period, wavelength, wave speed, and the energy. So all of these, they are under what we call waves. So these are the properties of wave, right? I know that we have, these are the main properties of waves that you need what? To take note of. Now the question is, how can you calculate what we call period? Let's start with period. So let's start with what we call period. So how can you calculate? Same period. Period is equal to what? If you follow, period to be equal to period, it is represented by t, so it will be 2 pi over angular frequency. Then we have also period, it is 1 over frequency. So we have also what we call frequency. So when it comes to the frequency, the formula is frequency is equal to angular frequency over 2 pi. Oh, I can say in another way, I can say frequency is equal to 1 over period, just like that. Then the other part, it's what we call the angular frequency. So when it comes to the angular frequency, in here, what you need to take note of, angular frequency is equal to 2 pi times frequency, or angular frequency is equal to 2 pi times what? Period. So all of these are the frequency sign. Then you have also what you call the wave speed. Now the question is, how do we calculate this wave speed? We calculate this wave speed by saying v is equal to, for now let's just know this because we have frequency times the wavelength, or if I want I can say wavelength over period. So these are the two formulas about the wave speed. Okay, now from there let's go to what we call the classification of what? Waves. Is it okay? So classification of waves. So what you need to understand is that when it comes to the classification of waves, waves are classified into two. The first classification of wave, it's what we call longitudinal, right? Waves. Or the other one, it is what we call compressional waves. So these are the waves that are being compressed, or longitudinal waves. So in longitudinal waves, what you need to take note of is that the particles of, say that longitudinal waves, take note of on this sign. So this is the first classification of the waves. We have longitudinal waves or compressional waves. So the particles in here in longitudinal waves are parallel. Is it okay? Are parallel to what? To the motion of a wave. Is it okay? So the particles are parallel to the what? To the motion. So particles in longitudinal waves, they are parallel to the motion. What do I mean? When the motion is going in this direction, even the particles, they will be parallel. So meaning that if the motion is here, even the motion will be there. So this kind of the waves, they are represented in this form. So when you see something that is like this, these are what we call longitudinal waves. So you shall see that there's one part that is more compressed, then the other part is not what? Compressed. So there's this part which is more compressed, and the other part which is not what? Compressed. So if you look, you shall see that this part, this is what we call, these are what we call the longitudinal waves or the compressed waves. the good example of these ones are what we call spring. Okay, so the good example of this kind of the wave are what we call spring waves. They're under that. And the other one, it's what we call the sound waves. So when it comes to the sound waves, they are also under this part, right? So this is what we call the longitudinal wave. Then the other part, it is what we call the transverse waves, right? So when it comes to the transverse waves, take note of something here. When it comes to the transverse wave, the particles, or in transverse wave, I'll say the particles in transverse waves, right, are perpendicular. Is it okay? So are perpendicular to the motion. Is it okay? So the particles in there, they are perpendicular to what? To the motion of the wave. And these ones, these are the ones that we were so familiar with them, because this is how they look like, right? So this is how they look like. Now the main examples when it comes to that, examples, we have water waves. Then we have also what we call the root waves. These are the main examples when you talk about waves. Okay, now let's understand something which is more important in here. Now, the other part that is so important when it comes to the wave, it is what we call mathematics, or mathematical, right? Or mathematics of what? Waves. Mathematics of waves. So this mathematics of the waves, they are represented in what we call pulses, right? That's where they are represented. Since they are represented in what we call pulses, and in simpler way, they are represented like y is equal to x t, then amplitude, sine, then k x plus or minus, k plus or minus, then angular frequency times time, then phase shift. So they are represented in this form. So in here, take note of this. That A that you see there, it is what we call the amplitude. Then the x, it is in distance or displacement, right? Then the other one, it is what we call w. It is what we call the angular frequency, right? Again, we have t. It is what we call the time. Again, we have also what we call theta. This theta which you see there, it is what we call the phase shift, right? So these are the main things that you need to take note of. Now the other part that you need to take note of, when here between it's positive like that, right? If it's positive, like that, just know that if it's positive here, you have seen here it's positive like that. So this means that the wave, right, is going to the negative direction, right? But when you see something like this, what does it mean? The wave is going to the positive direction. That's what it means. So if it's positive, meaning that the wave is going to the negative direction, but if it's negative, the wave is moving to the positive what? Direction. So that is what it means. Now, what we really need to take note of there is that you need to take note of there are formulas that are associated with this. So I'll do this. I'll say formulas for waves. So these are formulas for waves. So the main formulas for wave, what you need to understand is that we have K. Oh, sorry, I didn't indicate the K, this K here. So the K there, it is what we represent the wave number. Sorry for that, I didn't consider that. This is what we call the wave number. So how can we calculate the wavelength in this situation? So wavelength is equal to, right, in this situation, so to be 2 pi over wave number, right? Or I can say K is equal to 2 pi over wave number, like that, right? So that is what it means. And again, the other one which is more important, it's this one. Velocity is equal to wavelength over period, and wave velocity again is equal to frequency times the wavelength. Velocity again is equal to angular frequency over wave number. So all of these are formulas when it comes to this kind of the what formula. Is it okay? So those are the main things that you need to take note of. And the other thing that you require for us, it is this one. It is in period is equal to what? 1 over what? Frequency, or 2 pi over what? Angular frequency. I think these were so familiar with this. 1 over period, then angular frequency over 2 pi. Then angular frequency is equal to 2 pi times the frequency, like that. Angular frequency again is the angular frequency is 2 pi over period. So all of these are just the simple formulas that we really need to know when it comes to that. Okay, now let's look at the other one. I can say that wave speed on a stretched string, or I can say that in what? Solid medium. Is it okay? So This is the another thing, right? So now in here, how do we calculate this wave speed? We calculate this wave speed by saying modulus of velocity is equal to force tension over linear density. So when you look at this, this is what we call linear density, right? So this linear density, what is the linear density? The linear density, it is mass of a string. It is mass of a string over length of a string. Is it okay? So mass of a string and length of a string. That's what we call the linear density, right? So you may see something like m over l. So this is a situation most of the time you shall be asked a question that is having this. This is what you shall be asked with. And they'll put maybe the mass of this, or maybe 2 kgs. So what you need to understand here, this 2 kgs is not the one that you're supposed to put here. No. This 2 kg, it is the one that you use to calculate the force, or what you call the tension force. Don't calculate, don't put it here. No. They'll give you the mass of the string. Which string exactly? This string, this line here. They'll give you that. So that is the main thing that you need what? To take note of. Okay, now let's look at the other one. This is what we call the wave speed. The wave speed of what we call the wave speed in the, let me just say in the what? In the fluids. So how do we calculate this speed? We calculate this kind of the speed by saying V is equal to, right? We have what we call elastic property over what? Mainly initial property. Then the formula is this: Bulk's modulus over density. So this is B that you see, it is bulk modulus. Then this one, it is density. So you'll be given the density of the liquid which you have been what? Given. So, and the other part that we really need to know is that, remember that these waves, what do they carry? They carry energy, right? These waves, they carry energy. So now we need to understand that these waves, they have what we call kinetic energy, because they are moving, so they have kinetic energy. And how do you calculate this kinetic energy for them? You calculate the kinetic energy for them by 1 over, so this is the formula that we calculate, kinetic energy 1 over 4. Then linear density times, this is the linear density times the amplitude of the wave, then times the angular frequency, then times what? Wavelength. This is what we call kinetic energy. And even the potential energy, it is the same formula when it comes to that, right? When it comes to that, just the what? The same formula. And the other part that you need to take note of, it's what we call the total energy, right? So when it comes to the total energy in this situation, we're going to add kinetic energy is equal kinetic energy plus the potential energy. So in this situation, when you add this one plus this, you shall get to be 1 over 2 then a squared, that then wavelength. So that is what we call total energy, right? So that is what we call total energy. And you have what we call the power, right? Wherever there is energy, there is also what? Power, ability to do, or the rate at which work is being what? Done. So since you have the power, this power is calculated by power is equal to total energy over time. So when you say total energy over time, in that situation, you're going to say 1 over 2 like that. Then linear density times the amplitude also times what? Angular frequency times the velocity. So this is the formula that we use when it comes to what? To power. Then the other part is what we call the intensity. So intensity in this situation is a power per area. So it is the power per what? Per area. So in this situation, you're going to say intensity power over what? Area. And how do we calculate this area? We calculate the area by saying 4 pi over r squared. So if you haven't been given the area, this is what you do. You calculate the area like that, 4 pi then r squared. Okay, now let's go to the other part. I can say interference of waves. Interference of waves. So what you need to understand is that the waves, they interfered by two ways. So the first one, it is what we call constructive interference. That's the first one, constructive interference. So when it comes to the constructive interference, this happens when we have two waves with the same amplitude like this, right? So the amplitude is the same. So what happens is that when this and this meet, they will make a very big wave. This is the result of A plus what? B. And we call this as constructive what? Interference. So when they cross, the result is that they will continue with their what? Amplitude, just the way they are. And the other one, it is what we call destructive interference. So when it comes to destructive interference, this is a kind of the wave whereby you have the amplitude which is the same. So this is the crest which is up high. Then they have added with the another one which is coming with the crest, and the amplitude there, it is also the what? The same. So what happens in this situation is that there will be cancellation, right? So to be just straight, a cancellation of that waves, it is what we call destructive interference. So this is the end of waves. So these are the main things that we consider when it comes to the what? Waves. Make sure you like the video, subscribe the video.